This is a video walkthrough for practice 7D. In question 1, we're asked to decide which form of the equation to use when writing the equation for a quadratic function. If the vertex is known, then we should use the vertex form. If the x-intercepts or zeros are known, then we should use the factored form. In question 2, we have an equation that's given to us in vertex form, so that's going to tell us immediately what the vertex is. The vertex has an x value of -3 and a y value of -4. Remember that h is what's being subtracted from x, and since in the parentheses there is an x plus 3, that can actually be written as x minus -3. So the vertex is -3, -4. And the y-intercept can be found by replacing x with 0, since the y-intercept, or any point on the y-axis, will have an x-coordinate of 0. Now we just need to do some arithmetic. 0 plus 3 is 3, 3 squared is 9, so 2/3 times 9 is 6 minus 4 gives us 2, so that means our y-intercept is the point 0, 2. Let's plot the axis of symmetry, which will go directly through the vertex and will be a vertical line. And using symmetry, the y-intercept has a reflection on the other side of that axis that will give us the 3 points that we are looking for to provide a fairly accurate graph of this parabola. In number 2, we have a vertex form given again, so this vertex for this parabola is 2, 3. Let's plot that. And now we need the y-intercept, which can be found by replacing x with 0. Now we just need to do our arithmetic. 0 minus 2 is -2, and when we square that, we get a result of 4. Now we need to multiply that by -1 and add 3, which will give us a y value of -1, so the y-intercept is 0, -1. Let's go ahead and plot that. And let's remember that the vertex is a point that will be contained on the axis of symmetry. So our axis of symmetry is this vertical line right here that goes through the vertex. There's a reflection of the y-intercept on the other side of that axis that is also on the parabola, and that will give us our 3 points that we need to provide a fairly accurate graph there. In 4 through 5, we have a quadratic function whose equation is given in factored form. That will give us the x-intercepts immediately. -2 is the value that is subtracted from x in the first factor. So -2, 0 is an x-intercept. And we have a second x-intercept, 4, 0. Let's go ahead and plot those 2 points on the graph. Now remember, there's a symmetry to this graph. Since those 2 points have the same y value, the axis of symmetry must be located halfway between those 2 points, or equidistant from those 2 points. That will be that vertical line that has an equation of x equals 1. So we know immediately that our vertex has an x value of 1. So we can replace x with 1 in the equation and find y. So y is -1/3 times 3 times -3. Which gives us a value of 3. So our vertex is the point 1, 3. Let's go ahead and plot that. That's 3 points. That's enough to get a fairly accurate graph of what this parabola looks like. In 5, we have a factored form. That's going to give us the x-intercepts, which are 2, 0 and -6, 0. So those are our R1 and R2 values. And so let's go ahead and plot those. 2, 0, -6, 0. The vertex must be located halfway between those 2 points, at least horizontally. Since the points are 8 units apart, we can find the point that's 4 units to either side of those 2 points, and that will locate our axis of symmetry, which is the vertical line x equals -2. Knowing that the x value of the vertex is -2, we can use the equation to find the y value, replace all the x's with -2, y is equal to 3/8 times -4 times +4, which is 3/8 times -16, which would be -6. So our vertex is the point -2, -6. Let's plot that. That gives us 3 points. That's enough to get a fairly decent shape for this parabola. In 6 through 7, we have an equation that's given to us in standard form. And so we can use -b over 2a to find the x value for the vertex. The opposite of b is 8, and 2a is 4, so that means our vertex x value is 2. And so now let's use the equation to find the y value by replacing all of the x's with 2. That will give us 2 times 4 is 8, minus 16 plus 5, -8 plus 5 is -3. So our vertex is at the point 2, -3. Let's go ahead and plot that point. And then our y-intercept is the point when x is equal to 0. So that's 2 times 0 squared minus 8 times 0 plus 5 is 5. So the y-intercept is 0, 5. And we know that the vertex goes through the axis of symmetry. So I'm going to draw that in, and the y-intercept has a point that can be reflected to the other side, and it also sits on that parabola. So that gives us our 3 points, which is enough to provide a fairly accurate graph. In 7, we have another standard form equation. So the vertex x value can be found by using -b divided by 2a. The opposite of b is 2. 2 times a is 2 times -1/2, which is -1, and that's -2. We can find the y value by using the equation -1/2 times -2 squared minus 2 times -2 minus 3. And that's going to give us -1/2 times 4 is -2, plus 4 minus 3. And that's positive 2 minus 3 is -1. So our vertex is the point -2, -1. Let's plot that point. The y-intercept is the point where x is equal to 0. So -1/2 times 0 squared minus 2 times 0 minus 3. And that's equal to -3. So our y-intercept is 0, -3. We know that the vertex is contained on the axis of symmetry. So the y-intercept, if reflected over that axis, will provide us with that third point on the graph. And that gives us enough to provide a fairly decent graph. In 8 through 13, we need to choose the appropriate form for the equation of the parabola. In 8, since our x-intercepts are given, -5 and +3, that means that we can write the equation in factored form. Y equals a times x minus -5 times x minus 3. The only thing that we lack now is the value of a. The extra point can be used to find the value of a. The extra point has an x-coordinate of -3 and a y of 1, so I'm going to replace y with 1 and x with -3, and then use that resulting equation to find the value of a. So 1 is equal to a times 2 times -6, or 1 is equal to -12 times a, and that gives us an a value of -1/12. So the equation of this parabola is y equals -1/12 times x plus 5 times x minus 3. In 9, we are given this time a vertex, and our vertex has the coordinates 2, -5. That means that we can write this equation in vertex form. Y equals a times x minus 2 squared minus 5. The only thing that we lack is the value of a, and we can use that extra point to find the value of a. The coordinates of that extra point are -1, -2. So I'm going to replace y with -2 and x with -1. and then use that equation to solve for the value of a. So negative 1 minus 2 is negative 3, squared is 9, so we have 9 times a minus 3. Remember, those are unlike terms and cannot be combined. So adding 3 to both sides, 9a is equal to 1, and a is 1/9. So the equation of this parabola is y equals 1/9 times x minus 2 squared minus 5. In number 10, we have again a vertex at negative 3, 1. So the equation can be written in vertex form, y equals a times x plus 3 squared plus 1. And now we just need the extra point to help us find the value of a. The extra point is located at 0, negative 3. So I'm going to replace my y with negative 3 and my x with 0. Negative 3 is equal to a times 0 plus 3 squared plus 1. 0 plus 3 is 3 squared is 9. So now we have 9a plus 1 is equal to negative 3. Subtracting 1, negative 4 is equal to 9a, and a is negative 4/9. That gives us an equation. Y is equal to negative 4/9 times x plus 3 squared plus 1. In 11, the most appropriate form is factored form since x-intercepts are given at negative 3 and positive 4. So the equation in factored form is y is equal to a times x minus negative 3 times x minus 4. And so we can use our extra point, which has coordinates negative 1, 3, and replace y with 3 in the equation and x with negative 1. And that will help us find the value of a. A times negative 1 plus 3 times negative 1 minus 4 should equal 3. Negative 1 plus 3 is 2. Negative 1 minus 4 is negative 5. And so 3 is equal to negative 10 times a, and a is negative 3/10. That's going to give us a y value of negative 3/10 times x plus 3 times x minus 4. In number 12, factored form is again appropriate since we have x-intercepts at negative 4 and at negative 1. So the equation in factored form would be y equals a times x minus negative 4 times x minus negative 1. And we can use our extra point with coordinates 2, 4 to replace y with 4 and x with 2. And that will help us find the value of a. So 4 is equal to a times 6 times 3, or 4 is equal to 18 times a, and a is 4/18 or 2/9. So y is equal to 2/9 times x plus 4 times x plus 1. In 13, since we have the vertex, the most appropriate form would be vertex form. Our vertex is at 4, 0, which means that the equation is in the form y equals a times x minus 4 squared plus 0. Note that the plus 0 does not need to be written. Our extra point has coordinates 2, negative 3, so y can be replaced with negative 3 and x with 2 in order to find the value of a. So negative 3 is equal to a times 2 minus 4, which is negative 2 squared, is positive 4. So a is equal to negative 3/4, which makes the equation of this parabola y equals negative 3/4 times x minus 4 squared. In number 14, we are asked which form this is in. This is y equals ax squared plus bx plus c, so that's called standard form. The axis of symmetry can be found by using negative b divided by 2a. So negative b divided by 2a is the opposite of b, which is positive 6, divided by 2 times negative 3. So that's 6 divided by negative 6, which is 1. The y value of the vertex can be found by using the equation. So y is equal to negative 3 times negative 1 squared minus 6 times negative 1 plus 1. Negative 1 squared is positive 1 times 3 is negative 3. Negative 1 times negative 6 is positive 6. And finishing the rest of the arithmetic here, we have -3 plus 6, which is 3 plus 1 is 4. So that gives us a vertex with an x value of -1 and a y value of 4. The axis of symmetry has an equation, x equals -1. Remember, it's not just the number, it is the equation of that line, so that has to have a variable in it. The domain for any quadratic function is always all real numbers. The range, however, may be determined by the graph. Let's go ahead and we'll figure out what's going on with the graph in a moment, so we'll come back to the range. The y-intercept is found by letting x equal 0, but also the y-intercept when we're in standard form is always just the value of c, so the y-intercept is 0, 1. The value of a is a negative number. That means that our parabola opens downward. That's going to be important. So let's use that information so far to provide a graph, and we'll come back to the last two questions. So vertex is at -1, 4. The y-intercept is at 0, 1. Our axis of symmetry is a vertical line of x equals -1. That means that there is a reflection of the y-intercept that provides us with another point on the graph. And our parabola opens downward. We can kind of see that from that vertex and those other 2 points. And so now we can go back to the other 2 questions. The range is the set of all y values. The largest y value is at the vertex, and that's 4. So all other y values are less than 4. So that means that y has to be less than or equal to 4, equal at the vertex. That vertex is a highest value, so that is a maximum value of 4, and that occurs at x equals -1. All right, let's take a look at number 15. In 15, we have a factored form because it is factored. Our x-intercepts are 3, 0, and -1, 0. Those we can find from looking directly at the factored form. The axis of symmetry and the vertex have to be found indirectly. So if we were to graph the x-intercepts, 3, 0, and -1, 0, the axis is going to have to be halfway in between those 2 points. So that will be right there at x equals 1. So now we have the axis, and we have our x-intercepts. And, sorry, I put the vertex in the wrong place. Our axis is x equals 1. And our vertex, we know, now has an x value of 1. What is the y value? We'll find out from the equation. So let's take the equation and let's replace the x value with 1. And that gives us 3/4 times -2 times 2.